sorry, go ahead.
Okay, so, and I believe you touched on this prior to the lesson that I was looking at, but I found myself conflicting with the fact that the function f of t equals x doesn't have a function or an inverse.
Does not have an inverse. Okay.
Of f of negative t represents f of negative x, or opposite of.
Opposite of?
Correct.
That would be the second question, right? The negation is in the second question. In this one, are there any questions about this? Why this one has no inverse?
Yeah, just go ahead and if you could define it.
Okay.
It may be repeating. I apologize, but I just.
Okay, with this one, we can look at it as a picture, and we typically write the independent variable as the horizontal axis. So in this case, the independent one is the one on the left-hand side, because that's the one that we want to say, okay, can we express the right-hand side as a function of the left-hand side of the assignment statement? So in this case, we have, I just covered that part with this thing here. Okay, so in this case, we're talking about line 2. So on line 2, the independent one is actually t over, well, actually, yeah, it is t. And then the dependent one is the right-hand side, which is f of t, okay? So we want to plot this line. Now, knowing that f of t equals to x, and as far as this statement is concerned at this point, x is not being changed, okay? So x has a particular value at this point, and then we want to see, how t is going to get its own value because of x. Well, unfortunately, in this case, no matter what t value we are talking about, the f of t value is always going to be just the value of x at that point. Okay, so that means right after line 2 executes, we know that t and x have the same value. But there's no way to go back and say, okay, now that we know after line 2 t and x have exactly the same value, what was the value of t before line 2? There's no way to go back to figure it out, because t has a value of x, but what it was before can be anything.
So
that's why it has no inverse. That's why there's no way to reverse the operation, and that's why the inverse function does not exist.
Okay, I guess I was looking at it from, and you said before, more of a mathematics standpoint.
Okay.
Whereas I wanted to find the inverse of a number. The inverse of a number is just the opposite.
Oh.
So I guess that's kind of
Okay. So now that we know it has no inverse, we use the forget operation. And the forget operation looks like this. We basically just copy and paste the whole thing here. And we say x and t are the same at this point. And then the next thing we do is to actually carry out the forget operation. But there's really nothing to do, because the forget operation does not mention anything about t at all. So there's really nothing to forget in this case. And then we make a conclusion that x equals to t. Now that is also going, so I'm going to use the next line to do the implication, because what the first line, what this line implies is something like this, okay? We know x equals to m, and now we know x and t are the same. So we now also know that t equals to m, okay? So we can keep everything that we were highlighting, but we can also conclude that t and m are now exactly the same.
You're relating everything back to the constants.
Right. Yep. Because when we relate everything back to m and n, that means when we have to forget something about x or forget something about y, that is now independent. We are no longer relating t to x directly. We are now relating t to m, which we know doesn't change throughout this partial algorithm. Okay. So now we can work on the next one. The next one is line 3. We can say pre-3 equals post-2 because lines 2 and 3 are sequential. Okay. And then we can use exactly the same reason to determine what operation to use for line 3, because it's the same thing. The right-hand side of line 3 is f of x in this case is just y, and as a result there's no inverse. So we do pretty much the same thing. So we say post 3 is forget pre3, and we forget everything that we knew about x, because the new value that we put into x can invalidate all the relationship of x and other things before this. But after this, we can also claim x and y are the same, because that's the effect of this particular assignment statement. Okay, so we'll go ahead and just expand this. You can see this expression seems to be getting longer and longer, but at some point it will shrink. Okay, so I'm just expanding what is pre3, and now we can actually carry out the forget operation. To carry out the forget operation, we look at this whole thing here and say, okay, this mentions something about x, we cannot keep that anymore. This mentions something about x, we cannot keep that anymore. And this mentions something about x. Yeah, that mentions something about x, we cannot keep that anymore. And then on top of everything, we now know that x and y are exactly the same. Are we doing okay so far? Mm-hmm. Okay. I think this particular timestamp may be helpful. It's 10:49 right now, but I started the recording a few minutes late. So if you want to write it down, you can just write down 10:49, probably minus like 3 minutes or so, because I started recording late. It's because when I show you like this, if you watch the video, it will also show you which part I removed as a result of the forget operation. Okay. I could have used strike through or some other way to indicate it on screen, but instead I just kind of actually removed it. So watching the video will help you kind of visualize what is actually getting removed here. But I can also push this one more step, because I know how y relates to n or m. N or n are related now, and that will never change because we are not changing m or n in this particular pseudocode. We know t equals to m, but because x equals to y, now we also know that x equals to n as well at this point of the program. Are we doing okay so far with that implication? Okay. And that implication has to do with equality is transitive. X equals y and y equals z implies x equals z. It is transitive. Okay. And now we can work on line 4. So pre4 equals post3 because lines 3 and 4 are sequential. And then we basically do pretty much the same thing, because they're all kind of like that. Okay, the assignment statement only has one thing on the right hand side, but it's not the same thing on the right hand side. So now we have t and y, and once again there are no inverse functions. So now we can say post4 depends on forgetting something in pre4, and what we're forgetting would be things that we knew about y. But after this, we also know y and t are exactly the same. So now it's just a matter of expanding post3, which is this big mess here. And we'll forget everything that we knew about y. And then the next line is actually carrying out the forget operation. So we'll go ahead and copy the entire thing lying down here. And this time I'll go ahead and just use strike through, because I think it's one good way to indicate it. Okay, so this part we have to get rid of, because it states something about y and n, and that probably does not hold true anymore. At least we cannot guarantee it's holding true at this point. So we'll go to format, character, and then just go to font effect, do a strike through. I'll do a double strike through, or with X's. There we go. That looks kind of
hard to read.
Double strike through. You guys can pick. Okay, double strike through I think works okay. There we go. So this is struck through, stricken from the original, and this one has to be removed as well, because it relates to x and y. And once we change y, whether it equals to x cannot be guaranteed anymore. So we'll go ahead and do exactly the same thing, do a double strike through, and we say, okay, we don't know anything about y anymore. But don't forget the extra part here, y equals t, is outside of the forget operation, so you still have to add that part at the end of the whole thing. Okay, so now we have m is less than n, t is m, x is n, and y is t. But we can push this one more step, because we know that t equals m and y equals t, So we can also say that y equals m. Are we doing okay so far with this? Okay. All right. So that's post 4, and we are done with the post condition of the then portion. Now we work with the else portion. The else portion turns out to be pretty easy to work with because pre-6, what we know right before we execute line 6. Yep. Go ahead.
Why don't we state that y is smaller than x?
We can definitely do that. Okay, so we can also do more inferencing. So we can say m is less than n, t equals m, x equals n, y equals m, y equals t, and we can now also conclude. Let's see here. Y is less than x, right? Because x has the same value as n, so that would be fine. Now we don't really have to do any additional inferencing because we don't have any more forget operations after this line. So any type of extra inferencing is not going to be useful because we are not going to do any more forgetting at this point. Okay, but that's actually a useful conclusion. Y is less than x. Okay. Okay, because when we get to the post condition of the entire conditional statement, we'll see a pattern. Okay, so now we have pre-6. Pre-6 is the condition of the conditional statement itself, or the precondition of the conditional statement itself, which is pre-1, and the negation of the condition of the conditional statement, which is x is less than y, but that has to be negated because otherwise we won't be getting to the else branch.
If you put a negative sign in front of that, is that okay?
Huh?
If you put a negative sign in front of it?
No, because negation, the negative sign only applies to numerical value,
Okay.
but the not operation is a logical operation, so they're not really the same operation. I understand they are doing the inverse thing. Okay, it's reversing something so it can get to the identity, but they're not exactly the same thing either.
Okay, so I stated negative x is less than y, and then right next to that I also stated or.
That would be okay if you put the negation next to x itself. In other
No, it was
words,
outside of the parentheses.
Oh, okay.
Outside
Then
the
it's
parentheses.
not okay.
But then I also stated or to kind of simplify it. Y is greater than x.
I have to see it to
Okay.
determine. Okay. All right. So now we have pre-1. So we go back to pre-1 and just copy and paste it. Copy, paste. And then the other one is just really saying x is greater than or equal to y. And that's it. I mean, there's not a whole lot we really have to do here. If you want to, you can actually just add some extra stuff, which I think is kind of it will be helpful. X is m, and y is n, so m is greater than or equal to n in this case. All right. Are we still doing okay? Yep.
How tough are you grading this first one? Because I derived pretty much the same thing, but just a lot differently.
Okay, well, when we get to the bottom, then
Okay.
we'll talk about it. Okay, so now we have pre-6, then we have post-6, right? But post-6 is easy. Post-6 equals pre-6 because line 6 is an empty statement. An empty statement doesn't do a single thing, so none of the variables is getting affected as a result. So that's why the precondition becomes automatically the post-condition. There's nothing that happened on line 6. Okay, so line 6 is all done. Now we can move on to line 7. Post 7 is the disjunction of the two branches, the end of the two branches. In other words, in this case, it is post 4 or post 6. And at this point, it really is just a matter of copying and pasting. So post 4 is this big mess here. And then post 6 is just pre-6, which is this part here. A little bit of scrolling here, and it wrapped around. Okay, I'll line these two up so we can actually take a look and compare these two, portions of the disjunction. And that's our conclusion. Okay, at the end of this algorithm, the first part of the question, this is our conclusion. Yep.
So basically, Jehovah just made y become x and x become y.
But only if the ordering is opposite to when we first started. Okay. So when you look at these two conditions, one thing is constant. Okay, one thing is kind of always there. And that has to do with, y is less than x and y is less than or equal to x in the second case. Okay? So that means by the end of this entire algorithm, we are guaranteed that x is less than or equal to m. Right? Because it is present on both sides. Okay? X is less than m, y is less than x is specified in the first part of the disjunction, but that still implies y is less than or equal to x. Is that okay? Y is less than x implies y is less than or equal to x. Because of the or. Okay? So as a result, it doesn't matter which branch I came from, but when we are on line 7 or post line 7, we know one thing for sure. At that point, y is less than or equal to x. But that's easy to do. All I have to do is to make an assignment statement somewhere and say y gets 1 and x gets 2. That will get me to y is less than or equal to x in a hurry. But if you look at the rest of the conditions, it is also important because it is still it's saying that one of them is n, the other one is m. One of them is n, the other one is m. In other words, I'm only exchanging the values whenever it is necessary in order to make y less than or equal to x. Okay? Are there any questions about the effect of this particular conditional statement? You give me two values, okay? You give me a value x, you give me a value y. After this code, I will guarantee that y will be less than or equal to x. But each one, the original values, will still be in the two variables. Are we doing okay so far? This particular code, from line 1 to line 7, which is actually just the first part because the else branch is empty, is actually a very important step in bubble sort, which is an algorithm to sort an array of things. Okay, because bubble sort basically just bubbles up something, or you can say bubble down something. And the core of bubble sort is to say when two things are out of order, exchange them so that they're in the right order. And that's exactly what this particular code does. Now, getting back to the grading part, because we are kind of concerned about the grading part. The grading part will focus much more on why we are applying which rule. Okay, so this part is this is given, so obviously it's not worth any point. This is worth some points because it shows me that because of the structure of the conditional statement, this is the precondition of the entire then branch. And likewise, this shows me that you know how to work on the precondition of the entire else branch. The rationale of why we use the forget operation, that's also useful. This is useful because it shows me you know how to format a forget operation. This one is kind of useful, but not as useful because it shows me that you know how to expand it. And then of course the conclusion is useful as well. Now, how much you push, the constant and the m, so x, y, and t can relate to n or m. That is not as essential. Okay, so if you forget to do that part or you didn't do it exactly the way I did it, it's not going to be a major deduction. It's going to be quite minor. So don't worry about that part, but the other parts are important. Yep.
What about putting because lines 2 and 3 are sequential? Is that important?
That's a minor thing, because it's kind of obvious, but I still would like people to kind of indicate how do we connect the precondition of one thing to the post condition of the thing that's before that. Because otherwise there's no connection, right? Otherwise you have a post condition of line 2, and then how do you get started with the post condition of line 3? Yep.
So obviously it's wrong when you didn't do it, but in my post 7, I went on past where you went and
That's okay. You can go past.
That's not wrong.
Yeah, post 7. What I really will be looking at in terms of
I
post.
just put that X was greater than or equal to Y as the end of my post 7.
Okay, but that's fine. In post 7, I'm just looking for this, for the most part, and also just the expansion of post 4 and post 6. So for somebody who got post 4 wrong, but still understand the structure of post 7 and just copy and pasted the wrong post 4, that person will still get perfect score for post 7 itself, because the conclusion is still based on the structure of a conditional statement. So as long as that part is done, then post 7 is still okay. Yep.
And if I put a post 6 and a pre 7, is that
A post 6 and a pre 7. There's no such thing. There's no such thing as a pre 7, because pre 7 is ambiguous. Okay, are we talking about the end of the entire conditional statement, or are we only talking about the end of the else branch? Because there's always that kind of question. Okay, are we talking about just the end of the else branch or the end of the entire conditional statement? So that's why if you put in pre 7, I'm not going to take any points off, because it really does not need to be defined in the homework assignment. Any other questions about the first one?
What would happen if, can you scroll up a little bit? When you had added, you scroll over a little bit to the right.
Oh, okay.
Yeah. When you had added,
if you have additional stuff, I'm not going to take points off.
Okay, no, I was going to ask, when you had expanded one of the, lines earlier on. I wasn't quite following that, but I was wondering what the consequences would be if you didn't, the first T and M, right on line.
You mean here?
Yeah, I think that was, no, that wasn't.
If I did not expand that part, I would have lost the fact that T had the value of M when eventually Y gets the value of M. So I would not be able to conclude that Y ended up with the value of M if I did not do this extra step at this point.
I think I'm asking the question. I don't have it in front of me.
Okay. So the pushing the equality, is worth some points, but it's not going to be the major part of it. Okay. Any other questions? Okay, let's move on, and I'm going to change the view here to. There's another view which is not web layout. There we go. Okay, so this one doesn't give me the margins on the left and the right. It's just a little bit easier to see, but it won't let me open up 2 windows at the same time. Okay, that's the only way I can open up 2 windows. That's a little bit inconvenient. All right, so now we work on the second one. The second one also serves a particular function. It's actually a useful way to do a certain thing. So we'll take a look at what it's actually going to do. Pre1 is true, so we want to say, okay, what is pre2? Well, guess what? You still have to say pre2 is based on pre1, even though it is true, because this part depends on the structure of the code. So you still have to say that, and then later on, just simplify it to x is less than 0. Okay, that's pre2. And then I'll just work on the entire then branch first, and then we'll move on to the else branch. So now it's time to work on post 2. But how do we figure out what is post 2? Well, we do the same analysis that we did earlier with the first question. So we have to say the right-hand side of line 2 is f of x equals to the negation of x. So now the question is, does it have an inverse? Okay. What might be helpful is to just draw a picture, or plot out the value of negative x versus x itself. So here we have a graph. We have x, as the horizontal axis, and then we have negative x is the vertical axis. Okay. So when x is 0, negative x is also 0. So we have 0, 0, which is the origin, of the entire, graph. What happens when x has a value of 1? Negative x is negative 1. Okay, so we have a point down here. What happens when x has a value of negative 1? What is negative negative 1? Or the negation of 1? Positive 1, right? Okay, so now you can draw a straight line and basically say this is how x and negative x, or the negation of x, relate to each other. First question is, if I tell you that this point is at this height here, okay, so I give you the coordinate of the y-axis or the vertical axis, is there a way for me to know exactly where it would drop down onto the horizontal axis?
Yeah.
Yep, okay, so how do they relate to each other? It's the negation, right? So the inverse function is negation itself. Okay? F of x is the negation of x. The inverse function of f is also the negation of x. It is its own inverse. Okay? It's its own inverse because the negation of x is x. So it is its own inverse in this case. Are we doing okay so far with this method?
A little bit.
Now you can look at it the other way as well. Okay, let's look at it in some other way. Okay, let's look at it as f of x is k times x. Okay, and I'll just tell you that k does not equal to 0 because otherwise there's no inverse. Okay, so given that k is non-zero, I'm telling you that f of x is kx. What is the inverse function of x? Well, multiply has an inverse of what? Divided by, right? So in this case, x divided by k is the inverse. If this is 3 times x, this is x divided by 3. Does it make any sense? Okay. What if k is negative 1? The negation of x, the inverse of that is x divided by negative 1. But what exactly is x divided by negative 1? It's just the negation of x. So there are multiple ways to look at this and figure out, okay, the inverse function is itself in this case. There's another function where the inverse function is also itself, but this one is kind of trivial. Can someone give me an example where the function is its own inverse function? This one is so trivial that most of us will completely overlook it and go, oh, so that's what you meant, because it's like way behind us. Right? If f of x is x itself, then the inverse of that is also just x, because it doesn't do anything to x. So to undo not doing anything, we don't do anything. That is so zen. To undo not doing anything, we don't do anything. But that makes sense though, right? I mean, so there are cases where the inverse function is itself, okay? And these are, some of those cases. Okay, so in this case, we do have an inverse function. So the inverse function, and this time if you want to use, superscript, -1, that would be cool, but you don't have to, okay? So I'm just gonna do it just because I can. So we do the character, and then we go to font effect. Where is it? Position, there we go, superscript. There we go. All right. Okay, so we do have an inverse function. So which operation should we use? Use the substitution operation. All right. So to use the substitution operation, we are basically just saying, okay, the entire thing is the result of a substitution operation. We start with the precondition of line 2. every time we see the variable on the left-hand side, okay, let me just show you the original code here and then go back to the answer code. So on line 2, whenever we see x, we replace that with the inverse function of x, or the inverse function applied to x, and we use that to replace x. That's the first line. The second line is just an expansion of the first one. So we take the only little thing that we have in pre2, and then we specify the rest, and then f, in this case, the inverse function of f applied to x is really just the negation of x, because we know that they are exactly the same thing. And then on line 3, we just actually perform the operation. So we only have one x here. That becomes negative x. So negative x is less than 0 is the conclusion of the post condition of line 2. You can stop right here. I mean, you know, I don't need you to do the extra step, but personally, I would do the extra step because, you know, to say that the negation of x is less than 0 is really saying the same thing, which to me is a more clear way to state it, that x is greater than 0. Because when you apply negation to both sides of a comparison, you flip the comparison symbol.
Is that greater than or equal to? It's just greater than.
It's just greater than in this case. Okay. All right, so that's post 2, and now we can work on the other branch. The other branch, once again, is pretty easy to work with. Pre4 is pre1 because of the structure of the conditional statement, and the negation of x is less than 0. But in this case, the second one is x is greater than or equal to 0, because the negation of x is less than 0 means x can be 0 or it can be greater than 0. And we can now simplify that to just x is greater than or equal to 0. Post 5 is the disjunction of the two. So post 5 is post 2 or post 4, right? That has to do with the structure of the conditional statement when we merge the two branches. And now we can say, oh, but what is post 2? Post 2 is x is greater than 0. What is post 4? X is greater than or equal to 0. Okay? So the conclusion, you know, when you're standing at the junction of the conditional statement, you can basically combine x is greater than 0 or x is greater than or equal to 0 to what? Nope, it's the more general one. Because we are doing a disjunction, so we take the one that is more general. Because one is clearly inside the other one. Okay, x is greater than 0 is more specific, just a little more specific compared to x is greater than or equal to 0. When you're taking a disjunction, you're trying to make things more general, so you take the one that is including the other one. In this case, it's x is greater than or equal to 0. Okay. Are there any questions about this? No questions about this? Okay. Now, we only come to this conclusion, and it doesn't seem very hard for me to do something so that x is greater than or equal to x is greater than or equal to 0, because all I really have to do is to say x gets 0, and that will make this true automatically. So let's go ahead and see what happens when I add something to the precondition. Okay. What if I just say x equals to k in this case? Okay. So I'm propagating this change, you know, throughout the entire program now. Okay. It's really not that difficult. I mean, you know, we're just changing this to this, and we can no longer do the simplification, so that becomes this. And if you want to, you can say x is less than 0, right? I mean, that's the conclusion. Okay, so once we have that, we can also do the substitution operation just a little bit differently, because now we have the extra component here, because we can now say x equals to k is right here. This is before the actual substitution operation, and k is less than 0. And then after the substitution operation, we have negative x equals to k. And since we never really did anything to k, k is less than 0 will still be the same. So in this case, we'll say x equals to negative k, and x is greater than 0, and k is less than 0. There's no new information here. Are we still doing okay so far at this point? Okay. And then pre4 is about the same way, you know, except we have to kind of add certain things here. It's no longer true because pre1 is actually saying x equals k. So we have to add that fact here, x equals k here. And because x and k are exactly the same, we can also make a conclusion that x and k itself is greater than or equal to 0. So when you look at post 2 and post 4, now it is also a little bit different, but not really that difficult to figure out, because all we're going to do is to copy and paste our stuff around here. Okay. Here we go. All right, so if you take a look at this conclusion here, x is negative k and x is greater than 0 and k is less than 0, or x equals k and x is greater than or equal to 0 and k is greater than or equal to 0. What do you think this conditional statement is actually doing? It's a particular function that we encounter quite a bit in mathematics. It is taking the blah 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 value of x.
Absolute value.
The absolute value, exactly. This entire thing, this entire conditional statement, is actually just doing this. It's saying x gets the absolute value of x. Because when x is less than 0, then it flips the sign, so it becomes the other side. But if x is greater than or equal to 0, we're not going to do anything because it's already greater than or equal to 0. So that's what I meant when I said both of these pseudocode chunks actually do something that is useful in a larger context. All right. Are there any questions about the homework assignment? No questions? It's okay? All right. Now, once again, I added this extra piece, of information, later on. So that means you don't have to worry. But I didn't add that to my homework assignment. No, yours you only have to make sure that it works when the precondition of Lyman is true. Okay. All right. So now this is all done. I'm going to save it, and I can actually move it to the website. I'm not going to post the video until later tonight, but I can post the answer at this point. Let me turn on editing. Scroll to the right part, which is topic 3. Drag the answer here. There we go. And now we are ready to start on topic 5. Topic 4 is actually not really doing much. It's really just the exam scheduled. So we'll start with topic 5 now. And by the way, are there any questions about exam 1? Yep.
I just want to mention the roll sheet.
Roll sheet. Thank you. And the roll sheet is.
The exam's on Thursday, right?
The exam is this Thursday, the 10th. Correct. All right, topic 5, is it doesn't introduce any type of additional syntax, okay? It doesn't introduce any additional types of statements. It does introduce a new additional operator, okay, which is kind of like divide and addition, that sort of thing. It introduces a new operator called mod, okay, which is nothing more than just taking the remainder of a division instead of the quotient of a division. But what it does talk about is how do we approach a problem? How do we write algorithms? Okay, that's basically what this topic is all about. Okay, so what I'll do is I'm going to show you a few examples of top-down, or the necessity of a top-down way of looking at things. So I will start with, maps.google.com, and instead of looking at North Highland, we'll go ahead and zoom all the way out to the entire world. Okay. All right. So when you look at this particular picture, which is not the entire, well, I can actually just zoom out here. So this is kind of like a world map here. How many names are on this picture right now? Just give me an approximation. I don't need you guys to really actually count. 20, 30-ish. Okay, so if you give it a ballpark, 20, 30 would be a good ballpark. Okay, it may be slightly more than or less than 20 or 30, but that would be a right ballpark. Okay. So if I were to ask you to look for something, let's look for something that most of us do not know where it is, Mali. Okay, can you find Mali?
It's,
Okay.
western part of Africa.
Yep. And how about the rest of you who did not really take geography seriously in high school? How long would it take to find Mali? Not too long, you just have to kind of scan through the whole thing. Okay. What if on this picture we have 200 names because we're including the states of all the bigger countries? Like, the states of the United States, maybe Canada, or maybe China, or maybe Russia, because those are bigger countries and the states are pretty big too. That would become much harder to locate a particular name, right?
Still possible.
It's still possible, exactly. Okay, so in this case, if I want to tell you, okay, I want to find ARC, okay, American River College, and I want you to actually, pinpoint, not just say, it's around there, okay? Can you do that? No. No, but you know one thing about ARC that relates to this picture, don't you? Okay, what is that? It's in, well, first of all, it's in the northern hemisphere, right? It's in North America, and it's in a country called the United States. Okay, well, that's really useful, okay, because that really helps us and say, okay, which part do I have to zoom in order to find out a little bit more detail so I can locate American River College. Is that making any sense? Now, I know some of you are saying, yeah, but we can just type in the search bar and say American River College and press the enter key. Yes, but that kind of defeats the whole purpose of why top-down is an important way of looking at things, okay?
But doesn't that use the top-down to get to it?
No, it's a search engine thing, so it completely bypasses the whole process of top-down search and looking at things. All right, so we'll go ahead and do the same, do exactly that. We'll look at the United States and we'll zoom in maybe 2 levels, okay, right there. All right, so now we have, how many names do you think are on this picture at this point? It's a little more than before, I think, probably 30 to 40-ish. Well, there are 50 states already, right? And in each state, depending on the size of the state, it may include the capital and major cities, okay? So we figure maybe 60, 70 names or so, okay? Certain states definitely have more names, like California has 1, 2, 3, 4 names, but some states only have 1, like Utah only has the name of the state without even the state capital included. So we'll call that 70 names. Okay, with 70 names and assuming you know nothing about the geography of the United States, can someone search and find San Antonio quickly? Just assuming that you don't know anything about U.S. geography.
It's not really quickly,
Not quickly, but at the same time, it's not terrible, okay? Because you only have to look through, about 70 names, okay? Once again, I want to ask you, okay, can I pinpoint ARC on this map? And you will say, no, not quite. I know approximately where it is, but not exactly where it is, okay? But that's fine, because one thing in this particular picture is related to what you're looking for. What is it? The state of California. Okay, well, so we'll go ahead and zoom into, I think you guys know where I'm going with this, right?
American River College.
Sorry?
You go to American River College.
Okay, so now we can look at this map here and say, okay, we have about, I would say this time it's only about 20 names or so. It's fewer than the one before. And of these 20 names, which one do you think is related to what we're looking for? Sacramento. Very good. So now we zoom into, just Sacramento. Bing, bing. Only 2 levels at a time. Okay, so now we're looking at, the Sacramento map here. And which part do you think I should zoom into? Around citrus heights, because we are not exactly in citrus heights, but it's close. So zoom in 2 more levels. So we are around here, okay, somewhere between North Highland and Carmichael. Okay, zoom in 2 more levels. And now we get quite a few more names on the map, but it's still kind of manageable, right? It's still manageable. Of all the names that you see here, which one do you think is related to the location here, at ARC? Okay, we know Madison is one of the main streets that is close to ARC. It's not exactly a cross street. Which other one would you pick? It doesn't really show. It's actually, College Oak Drive is, I think, about here. But it's closer. Okay. But the main point is, every time we zoom in, it only displays, at the most, tens of names. Okay, maybe 70. Okay, 70 or 80. But it doesn't give you like thousands upon thousands of names to search through. Okay, and that's because we can't really search through that many names quickly. It's overwhelming, and it's also ineffective, right? I mean, it's much easier if we can just kind of zoom in and then show a few more names, zoom in, show a few more names.
Yeah,
and
if at this level you showed all the street names, you'd have
the major
names over names over names that you really.
Right. And that's why it only shows the major, the major streets and the major roads. It doesn't show every single road, every single street. Okay? And that's the whole idea of a top-down approach is, you limit the number of items that you have to focus on at each level. But why are we doing that? Oh, it's because this screen has a limited resolution. That's why. Well, what if I tell you I have a magical projector that has an infinite resolution? If you want to go from 300 dpi to 6,000 ps of dpi, no problem. I flip a switch and the resolution just bumps up. Even if the screen is capable of an infinite resolution and I give you loops so you can actually look through the details on the map, the problem is what?
Well, I was gonna say, it's kind of like how they make social security numbers to be the 9 numbers or whatever, because
The 9
it's
digits?
the most that we can remember.
And
Like, if
for
they
people
put
like
any
me,
more-
give me more than 3 digits and I cannot remember.
If
Okay,
you put any more than that on the screen, we won't be able to process it.
Yep, our short-term memory is definitely limited. But even if I give you like 20 names and I just want you to locate one of the 20 names, that's that's also a limitation. Okay.
Yeah, but for a computer with processing power, it's more logic.
It is logical.
Versus, there's more of a logical reason to limit the selections than there is like a person focusing on something.
Well, it's both resources
Potentially.
though. One's just computer resources, the other one's mental resources.
Potentially, but when you're writing a program, when you're developing a program, when you need to track your program and say, okay, from here, where do I go? It's still limited to, what you can keep track of at that particular time of your program.
That's true.
Okay, and it's another way to illustrate this is the lack of top-down approach. Okay, and all we have to do is to go to AAA, and get one of those actual maps. Okay, and then to really help to illustrate this point, we will erase or white out the index on the back of the map. And then I'll ask you guys to find, a particular street that is a small street, somewhere on the map. That illustrates the difficulty of that approach. Okay, because now it's on the map. It's not like the map is missing that street. It is on the map. But how do you search through, hundreds upon hundreds upon hundreds of names? Yep.
My parents both went to college in San Francisco and they grew up in Sacramento. And they told me that when they moved there, they used maps. And I just stared at them dumbfounded. How in the world did you find your way anywhere? Looking at those things, it's
In San Francisco, it's not just a way to some place. It's also which way.
Yeah.
Because they have a lot of one-way streets.
The amount of information on them is just substantial.
Yep. Go ahead.
So is that the same idea behind mass storage? When you have a 2 terabyte hard drive, it's actually hard. They have to use a different type of locating file system because
Right.
trying to follow.
Exactly.
It's filled up. It's so hard.
That's exactly why when you have a file system, and let's say it's something that you actually personally have to deal with. So it's not like something that a program manages. Okay, it is something that you have to personally go in and inspect the files or the folders. how many files or folders can you put into another folder before you say, okay, this is getting hard to find stuff?
So it's
Okay.
like trying to find a grain of sand in a cup versus a warehouse.
Something like that, or you can put, dices in a cup, because you can only put about 20 in the cup, right? As opposed to in a bucket. Yep.
It was kind of like your analogy, if you put all your files in one folder, like there were no folders.
Exactly. Yep.
There's just too much, but if you do that.
Yep. Okay, but what is the limit? What is limiting, how many files you can put into a single folder before you say, okay, I think I need, more organization at this point? What is the limiting point?
What's easy to look at?
Sorry?
Like what's easy to look at? What's easy to
Okay, you're definitely getting closer, okay? And what limits that? What limits, how many things you can search through conveniently just by glancing over it?
Attention span?
Attention span, okay, but there's certain things are related to the screen itself. How tall it is, right? The moment you have so many files that you have to scroll like page down 3 times to go from the first file to the last file, it's definitely getting hard to find a file, right? But if all the files can still fit on one page, you can still kind of glance through and go and find the right file. Okay?
But if there's some organization to it, say
Right,
all
alphabetically ordered,
alphabetical or numerical
that helps.
That helps.
That helps.
Still, if you got 1,000 files, that's
Exactly.
cumbersome. Why
Yep,
not?
it's still not easy because you still have to scroll, because okay, let's say you're trying to find the name a city, within a list of thousands of cities in the United States, okay, and let's say you know exactly how the city is supposed to be spelled.